Welcome to Heavenly Sleep Stories, a place where but also the countless possibilities for stars, planets, and perhaps even life beyond our own Milky Way. Fact 12. The Milky Way contains over 100 billion stars. Our home galaxy, the Milky Way, is a sprawling spiral galaxy that contains over 100 billion stars. These stars vary widely in size, age, and temperature, from small, dim red dwarfs to massive, hot blue giants. The Milky Way also contains a mixture of gas, dust, and dark matter, all contributing to its dynamic structure and evolution. Our solar system is located in one of the spiral arms, known as the Orion Arm, about 27,000 light-years from the galactic center. The vast number of stars means that the Milky Way likely hosts an enormous number of planets, many of which could be similar to Earth. Studying the stars in our galaxy provides insights into the life cycles of stars, the formation of planets, and the processes that govern galactic evolution. Stars in the Milky Way are constantly moving, interacting gravitationally, and sometimes colliding or forming clusters. Understanding the Milky Way is essential for contextualizing our place in the universe and for exploring the possibilities of life beyond Earth. Even with its immense size, the Milky Way is just one galaxy among trillions, emphasizing the incredible scale of the cosmos. Fact 13. Galaxies can collide and merge. Galaxies are not isolated. They often interact with each other, sometimes leading to collisions and mergers. Despite the dramatic term, these cosmic encounters occur over millions to billions of years and involve vast distances between individual stars, so direct star-to-star collisions are rare. When galaxies collide, their gravitational forces distort their shapes, triggering bursts of star formation as gas clouds compress and collapse. Such mergers can result in entirely new types of galaxies, combining elements of the originals. For example, the collision between two spiral galaxies can produce a massive elliptical galaxy. Observations of interacting galaxies, such as the famous antennae galaxies, provide striking visual evidence of these cosmic events. Galaxy collisions also influence the growth of supermassive black holes at their centers, feeding them with gas and dust. Our own Milky Way is expected to collide with the Andromeda Galaxy in about 4 billion years, resulting in a merged galaxy sometimes called Milkomeda. Understanding galaxy collisions helps astronomers trace the evolution of galaxies over time and reveals the dynamic and interconnected nature of the universe. These cosmic dances are a reminder that the universe is not static but constantly changing and evolving. Fact 14. Elliptical galaxies are older than spiral galaxies. Elliptical galaxies are among the oldest structures in the universe. Unlike spiral galaxies, which contain young, hot stars and actively form new stars, elliptical galaxies are dominated by older, cooler stars, giving them a reddish appearance. These galaxies often have little gas and dust left, meaning that star formation has largely ceased. Many elliptical galaxies formed early in the history of the universe, through mergers of smaller galaxies and gravitational interactions that smoothed out their structure. Their spherical or elongated shapes contrast with the flat, rotating disks of spiral galaxies, reflecting their different formation histories. Elliptical galaxies are commonly found in dense regions of the universe, such as galaxy clusters, where gravitational interactions are frequent. Studying them provides valuable insight into the early stages of galaxy formation and the effects of mergers on galactic evolution. Their older stars contain clues about the chemical composition of the universe billions of years ago. Recognizing that elliptical galaxies are older than spiral galaxies helps scientists understand the timeline of cosmic development and the life cycles of galaxies across the universe's vast history. Fact 15. Our Sun is a middle-aged star. The Sun, our life-giving star, is considered a middle-aged star. It is approximately 4.6 billion years old, about halfway through its expected 10 billion-year lifespan. Classified as a G-type main sequence star, or yellow dwarf, the Sun produces energy through nuclear fusion, converting hydrogen into helium at its core. This process releases the light and heat that sustain life on Earth. Being in the middle of its life cycle, the Sun remains stable in terms of size and luminosity, providing consistent energy output. Eventually, in several billion years, it will exhaust its hydrogen fuel and expand into a red giant, potentially engulfing the inner planets, including Earth. After shedding its outer layers, the Sun will leave behind a dense white dwarf, gradually cooling over trillions of years. Studying the Sun gives scientists critical insights into the life cycles of stars, solar activity, and the dynamics of planetary systems. Understanding that our Sun is middle-aged also provides context for the development of life on Earth, emphasizing that we live in a relatively stable period in its evolutionary journey, which has allowed life to flourish over billions of years. Fact 16. Stars are born in nebulae. Stars are formed in vast, dense clouds of gas and dust known as nebulae, often referred to as stellar nurseries. These nebulae contain primarily hydrogen, along with helium and trace amounts of heavier elements, which serve as the raw materials for star formation. Gravity causes regions within the nebula to collapse, increasing pressure and temperature until nuclear fusion ignites in the core, marking the birth of a new star. During this process, the surrounding gas and dust may form a rotating disk, from which planets and other celestial bodies can eventually emerge. Famous examples of star-forming nebulae include the Orion Nebula and the Eagle Nebula, which contain clusters of newly formed stars visible in stunning astronomical images. Star formation is not instantaneous. It occurs over thousands to millions of years, with protostars gradually accumulating mass and shedding excess material. Understanding star formation helps astronomers trace the life cycle of stars and the evolution of galaxies. Nebulae, with their vibrant colors and dramatic shapes, are not only visually striking but also fundamental to the cosmic process that generates the building blocks of solar systems and, ultimately, life. Fact 17. Red giants are dying stars. Red giants represent a late stage in the life cycle of stars like our Sun. When a star exhausts the hydrogen fuel in its core, nuclear fusion slows down, and the core contracts under gravity while the outer layers expand dramatically. This expansion cools the surface, giving the star a reddish hue and earning it the name red giant. Despite their cooler surface temperature, red giants can become thousands of times larger than their original size, sometimes even engulfing nearby planets. During this stage, helium fusion begins in the core, creating heavier elements like carbon and oxygen. The red giant phase is a transitional period that eventually leads to the shedding of the star's outer layers, forming planetary nebulae and leaving behind dense remnants such as white dwarfs. Studying red giants allows scientists to understand stellar evolution, predict the future of stars like the Sun, and observe the creation of elements that are essential for planets and life. These dying stars are a reminder that all stars, no matter how massive, undergo transformation and that their eventual death contributes to the ongoing cycle of matter in the universe. Fact 18. White dwarfs are remnants of stars. A white dwarf is the dense remnant left behind after a star like the Sun has exhausted its nuclear fuel and shed its outer layers. These stellar remnants no longer undergo fusion, but they retain enormous mass packed into a volume roughly the size of Earth, resulting in extremely high densities. White dwarfs are incredibly hot when they form, emitting residual thermal energy, but they gradually cool over billions of years. Some white dwarfs are found in binary systems, where they can accumulate matter from a companion star, potentially triggering explosive events known as novae. These remnants provide critical insights into stellar life cycles, the fate of medium-sized stars, and the chemical evolution of galaxies. By studying white dwarfs, astronomers can estimate the ages of star clusters, offering a glimpse into the history of the universe. Although they are no longer active in fusion, white dwarfs represent the enduring cores of once luminous stars, preserving the history of stellar evolution and contributing to the cosmic ecosystem that forms new stars, planets, and ultimately, life. Fact 19. Supernovae create heavy elements. Supernovae are among the most powerful and dramatic events in the universe, marking the explosive death of massive stars. During a supernova, the star's core collapses, releasing enormous energy and blasting the outer layers into space. This process not only produces spectacular light shows, but also creates heavy elements such as gold, silver, uranium, and lead, which are essential for planets and life. These elements, forged in the heart of dying stars, are scattered into space and later incorporated into new stars, planets, and even living organisms. Supernovae also trigger shockwaves that compress surrounding gas clouds, stimulating the formation of new stars. Observing supernovae allows astronomers to measure cosmic distances, understand stellar evolution, and study the distribution of elements in galaxies. Without supernovae, the universe would lack many of the elements necessary for complex chemistry and the development of life. These colossal explosions remind us that destruction and creation are intertwined, and that the death of stars plays a critical role in shaping the universe and the material foundations of planets, including our own Earth. Fact 20. Neutron stars are incredibly dense. Neutron stars are one of the densest forms of matter in the universe, formed when massive stars collapse after a supernova. Despite having a diameter of only about 20 kilometers, a neutron star can contain more mass than our Sun, resulting in mind-boggling densities where a single teaspoon of neutron star material would weigh billions of tons on Earth. Neutron stars are composed almost entirely of neutrons packed tightly together, and their gravity is immense, warping space-time around them. Many neutron stars rotate rapidly, emitting beams of electromagnetic radiation that can be detected as pulsars when these beams sweep past Earth. Studying neutron stars provides insights into the behavior of matter under extreme pressures and densities, the limits of physics, and the life cycles of massive stars. They also help scientists test theories of general relativity and explore exotic states of matter that cannot be replicated in laboratories. Neutron stars are cosmic laboratories, demonstrating the incredible extremes the universe can produce, and highlighting the diversity and complexity of stellar remnants that continue to shape galaxies and the cosmos. Fact 21. Black holes have gravity so strong that not even light can escape. Scientists study wormholes not only as a tool for understanding fundamental physics, but also as a way to explore concepts like time travel, causality, and the structure of the cosmos. While still purely theoretical, wormholes capture the imagination of both scientists and the public, highlighting how the universe may contain possibilities far beyond our current technological or observational reach. They serve as a reminder that space-time is not a fixed backdrop, but a dynamic and potentially traversable fabric, limited only by the laws of physics and our understanding of them. Fact 27. Quasars are extremely luminous objects powered by black holes. Quasars are among the brightest objects in the universe, emitting incredible amounts of energy, often outshining entire galaxies. These luminous beacons are powered by supermassive black holes at the centers of galaxies. As matter falls toward the black hole, it forms an accretion disk, where friction and gravitational forces heat the material to extreme temperatures, producing intense radiation across the electromagnetic spectrum. Quasars can be observed across billions of light years, providing a glimpse into the early universe. The study of quasars helps astronomers understand galaxy formation, black hole growth, and the distribution of matter in the cosmos. Quasars often release powerful jets of energy that can extend thousands of light years into space, influencing star formation and the evolution of surrounding gas. Because they are visible at extreme distances, quasars serve as cosmic lighthouses, allowing scientists to probe the expansion of the universe and the large-scale structure of matter. These extraordinary objects demonstrate the immense power of black holes and the dynamic processes that drive energy release on cosmic scales, offering insights into both the past and the present universe. Fact 28. Pulsars are rotating neutron stars emitting radiation. Pulsars are a type of neutron star that rotates rapidly, emitting beams of electromagnetic radiation from their magnetic poles. As the pulsar spins, these beams sweep across space like cosmic lighthouses, and if aligned with Earth, they are observed as periodic pulses of light or radio waves. Pulsars are formed from the remnants of massive stars after supernova explosions, leaving behind incredibly dense cores. and astrobiologists gain insights into what makes a planet habitable and what conditions might be required for life elsewhere in the universe. Earth's uniqueness emphasizes the delicate balance necessary for sustaining life and reminds us of the responsibility to protect our planet's environment. Fact 40. Pluto is classified as a dwarf planet. Pluto, once considered the 9th planet of our solar system, is now classified as a dwarf planet. This reclassification, made by the International Astronomical Union in 2006, reflects Pluto's inability to clear its orbit of other debris, a key criterion for full planetary status. Pluto is located in the Kuiper Belt, a region of icy bodies beyond Neptune, and has a highly elliptical and inclined orbit. Despite its small size, about 2/3 the diameter of Earth's moon, Pluto has a complex surface, with mountains, valleys, ice plains, and a thin nitrogen atmosphere that can expand and contract as it orbits the Sun. Pluto has 5 known moons, the largest being Charon, which is nearly half the size of Pluto itself. The study of Pluto provides insight into the formation of the outer solar system, the behavior of icy bodies, and the diversity of planetary types. Its reclassification sparked public interest and debate, but also enhanced our understanding of what defines a planet. Pluto remains a fascinating and enigmatic world at the edge of our solar system. Fact 41. Jupiter has over 90 moons. Jupiter, the largest planet in our solar system, has over 90 known moons, making it the planet with the most satellites in the solar system. These moons vary widely in size, composition, and origin, ranging from tiny irregularly shaped bodies to massive moons larger than some planets. The 4 largest, known as the Galilean moons, Io, Europa, Ganymede, and Callisto, were discovered by Galileo Galilei in 1610 and remain among the most studied celestial bodies. Io is the most volcanically active body in the solar system, while Europa is a prime candidate in the search for extraterrestrial life due to its potential subsurface ocean. Ganymede, the largest moon in the solar system, even has its own magnetic field. Jupiter's many moons are held in orbit by its immense gravity and interact with each other through gravitational forces, creating complex orbital resonances and tidal effects. Studying Jupiter's moons helps scientists understand planetary formation, the diversity of celestial bodies, and the dynamics of satellite systems. These moons also provide potential targets for future exploration and the search for life beyond Earth. Fact 42. Saturn has more than 80 moons. Saturn is orbited by more than 80 known moons, each exhibiting unique features and characteristics. These moons range from tiny, irregularly shaped satellites only a few kilometers across to large, geologically complex moons such as Titan and Enceladus. Saturn's moons interact gravitationally with the planet's massive ring system, creating gaps, waves, and shepherding effects that shape the rings over time. Many of Saturn's moons are composed primarily of ice, with some showing evidence of cryovolcanism, tectonic activity, or subsurface oceans. Titan, Saturn's largest moon, is particularly notable for its thick nitrogen-rich atmosphere and methane lakes, which make it a subject of intense scientific interest. Saturn's diverse moons provide insights into the formation and evolution of planetary satellite systems, the processes shaping icy worlds, and the potential for habitability beyond Earth. Studying Saturn's moons not only helps astronomers understand the dynamics of the Saturnian system, but also offers a window into the broader processes at work in the outer solar system, highlighting the complexity and richness of celestial objects orbiting gas giants. Fact 43. Titan, Saturn's largest moon, has a thick atmosphere. Titan, the largest moon of Saturn, is unique because it possesses a thick atmosphere, primarily composed of nitrogen with traces of methane and other hydrocarbons. This dense atmosphere is even denser than Earth's at the surface, creating pressure conditions that could allow liquid hydrocarbons to exist in rivers, lakes, and seas. Titan's atmosphere ejecting water vapor and ice particles that contribute to Saturn's E-ring. Cryovolcanism is typically driven by tidal heating, where the gravitational pull from a parent planet flexes the Moon's interior, generating heat. Ice volcanoes are of immense scientific interest because they may indicate subsurface oceans, which could provide habitable environments for life. Studying these moons helps scientists understand geological processes under extreme conditions, the potential for life beyond Earth, and the dynamics of icy bodies in the outer solar system. Ice volcanoes reveal that even distant, frozen moons are active worlds with complex and fascinating geological behavior. Fact 48. Ceres is a dwarf planet in the asteroid belt. Ceres is the largest object in the asteroid belt between Mars and Jupiter and is classified as a dwarf planet. Measuring about 940 kilometers, 585 miles, in diameter, Ceres accounts for roughly 1/3 of the mass of the entire asteroid belt. Its surface is a mix of water ice, clay, and rocky material, with some bright spots identified as salt deposits. Evidence suggests that Ceres may have a subsurface layer of briny water, raising questions about its potential for supporting microbial life. The dwarf planet has a thin, tenuous atmosphere composed of water vapor and may experience occasional cryovolcanic activity. NASA's Dawn mission provided detailed images and measurements, revealing craters, mountains, and other geological features that hint at a complex history. Studying Ceres helps scientists understand the formation and evolution of the solar system, the transition between asteroids and planets, and the presence of water in unexpected places. Ceres represents a bridge between small rocky bodies and fully formed planets, making it an invaluable object for planetary science and exploration. Fact 49. Halley's Comet returns every 76 years. Halley's Comet is one of the most famous comets, known for its predictable return to the inner solar system approximately every 76 years. This short-period comet travels along an elongated elliptical orbit, passing close to the Sun and becoming visible from Earth as a bright object with a glowing coma and a long tail of gas and dust. Halley's Comet has been observed and recorded by humans for millennia, with historical sightings dating back to ancient civilizations, influencing culture, science, and astronomy. As it approaches the Sun, solar radiation causes the icy nucleus to sublimate, releasing gas and dust that form the characteristic tail pointing away from the Sun. Studying Halley's Comet provides insights into the early solar system, as comets are remnants of its formation, preserving pristine material from billions of years ago. Each return allows astronomers to refine orbital predictions, understand cometary composition, and explore interactions with solar wind and radiation. Halley's regular appearances remind us of the dynamic nature of our solar system and the long-term cycles of celestial objects. into the formation of black holes, the physics of relativistic jets, and the early universe, as many occur at extreme distances, offering glimpses into the first generations of stars. Studying GRBs also helps scientists understand the potential hazards of cosmic events for life on Earth and the mechanisms that drive extreme energy release in the universe. Their sheer power and rarity make gamma-ray bursts some of the most fascinating cosmic phenomena ever observed. Fact 53. Cosmic rays are high-energy particles from space. Cosmic rays are high-energy particles originating from outer space, including protons, atomic nuclei, and electrons. Traveling near the speed of light, these particles constantly bombard Earth's atmosphere, producing showers of secondary particles and ionizing radiation. Cosmic rays come from various sources, such as supernovae, gamma-ray bursts, and active galactic nuclei, carrying information about energetic processes in the universe. When they collide with molecules in Earth's atmosphere, they create particles like muons, which can reach the surface and even penetrate deep underground. Cosmic rays influence the chemistry of the atmosphere, may affect cloud formation, and pose a radiation hazard to astronauts and high-altitude flights. Studying cosmic rays allows scientists to explore astrophysical phenomena, particle physics, and the origin of elements in the universe. Instruments both on Earth and in space, including satellites and detectors, measure cosmic rays, helping researchers understand the extreme environments and energetic processes that produce them. Cosmic rays are invisible messengers from distant parts of the universe, constantly connecting Earth with the vast cosmos. Fact 54. Solar flares can affect Earth's magnetosphere. Solar flares are intense bursts of radiation from the sun's surface, caused by sudden releases of magnetic energy. When directed toward Earth, these flares can affect our planet's magnetosphere, disrupting satellite communications, GPS signals, and power grids. Solar flares also enhance the flow of charged particles in the solar wind, leading to connection between our planet and the dynamic environment of the Sun. Auroras remind us of the intricate forces shaping our atmosphere and the beauty resulting from cosmic interactions. Fact 56. Neutrinos can pass through entire planets. Neutrinos are tiny, nearly massless subatomic particles that are produced in enormous quantities by the Sun, supernovae, and other cosmic events. Remarkably, neutrinos can pass through entire planets, including Earth, without being stopped or absorbed, because they interact extremely weakly with matter. Trillions of neutrinos pass through every square centimeter of your body every second, yet they are almost impossible to detect. Scientists study neutrinos to understand nuclear reactions in stars, the mechanisms of supernova explosions, and fundamental particle physics. Special underground detectors, often located deep in mines or beneath ice, are used to shield instruments from cosmic rays and background radiation, allowing the rare neutrino interactions to be observed. Neutrinos also provide a unique window into the interior of stars and the core of the Sun, as they escape almost immediately after production. Studying these elusive particles helps scientists probe the universe's most extreme events and contributes to understanding the fundamental building blocks of matter. Their ghost-like ability to traverse planets highlights the strange and fascinating nature of the subatomic universe. Fact 57. Gravitational lensing bends light around massive objects. Gravitational lensing is a phenomenon predicted by Einstein's theory of general relativity, where massive objects bend the path of light from distant sources. When a massive galaxy, cluster, or black hole lies between an observer and a distant light source, its gravity warps spacetime, causing the light to curve around it. This effect can produce multiple images, arcs, or even complete rings of the relativity, nothing with mass can travel faster than light, making it a fundamental limit for information and energy transfer. Light's speed determines the structure of space-time, the behavior of electromagnetic waves, and the causality of events across the cosmos. Measuring distances in astronomy often relies on light travel time. For example, the distance to the nearest star system, Proxima Centauri, is expressed as 4.24 light-years, meaning its light takes over 4 years to reach Earth. Light speed also underpins technologies such as fiber optic communication, GPS, and astronomical observations. When light passes through materials like water or glass, it slows slightly, but in vacuum, it represents the ultimate cosmic speed limit. Understanding the speed of light is essential for physics, cosmology, and modern technology, defining how we perceive distance, time, and motion in the universe. Fact 64. Light from the Sun takes 8 minutes to reach Earth. Light from the Sun takes approximately 8 minutes and 20 seconds to reach Earth, traveling across a distance of about 149.6 million kilometers, 93 million miles. This time delay means that we always see the Sun as it was over 8 minutes ago, not as it exists at the exact moment of observation. The finite speed of light affects our understanding of astronomical events, as observing distant stars and galaxies is equivalent to looking back in time. The Sun emits electromagnetic radiation across the spectrum, including visible light, ultraviolet, and infrared, which travels through the vacuum of space to sustain life on Earth. Solar energy drives climate, weather, and photosynthesis, highlighting the importance of sunlight in maintaining our planet's ecosystems. This 8-minute light travel time also serves as a reminder of the vast distances in our solar system and the universe, dust and organic compounds, while certain asteroids, particularly carbon-rich ones, also contain hydrated minerals. When these objects collide with planets, they can deposit water and other elements necessary for life. Observations from space missions, such as ESA's Rosetta spacecraft and NASA's OSIRIS-Rx, have confirmed the presence of water ice and other volatile compounds in these celestial bodies. Understanding the distribution of water in comets and asteroids helps scientists reconstruct the history of water in the solar system, the origin of Earth's oceans, and the conditions that may allow life to develop elsewhere. Water-rich comets and asteroids illustrate how even small objects in space can have a profound influence on planetary evolution and habitability, highlighting the interconnectedness of cosmic processes. Fact 79. Some stars have planets with extreme climates. Not all planets experience mild or Earth-like conditions. Some stars host planets with extreme climates. For example, hot Jupiters are gas giants that orbit very close to their stars, experiencing intense heat and stellar radiation, often leading to atmospheric escape and supersonic winds. Conversely, some exoplanets orbit far from their stars and are extremely cold, with frozen surfaces and potentially solid atmospheres. Planets can also be tidally locked, meaning one side constantly faces their star while the other remains in perpetual darkness, creating dramatic temperature differences. Studying these extreme climates helps scientists understand the diversity of planetary systems, the effects of stellar radiation on atmospheres, and the potential limits of habitability. Observations of these planets challenge traditional models of planetary formation and evolution, revealing the adaptability of planetary environments to various stellar conditions. Extreme exoplanets expand our knowledge of the variety of worlds in the universe and inspire curiosity about what conditions life might endure elsewhere. Fact 80. SETI searches for intelligent extraterrestrial life. The search for extraterrestrial intelligence, SETI, is a scientific effort to detect signals from intelligent life beyond Earth. Using radio telescopes, optical instruments, and other observational methods, SETI researchers monitor stars and galaxies for patterns or transmissions that could indicate deliberate communication. This search is motivated by the vast number of stars and planets in the galaxy, suggesting that intelligent life could exist elsewhere. SETI initiatives involve analyzing unusual radio bursts, laser pulses, and Some black holes can emit jets of energy. While black holes are famous for their extreme gravity that prevents anything, even light, from escaping, some black holes can emit powerful jets of energy from their surrounding regions. These jets, known as relativistic jets, occur when material falling toward a black hole forms an accretion disk. Magnetic fields around the black hole can accelerate particles to nearly the speed of light, creating narrow beams of energy that shoot out perpendicular to the disk. These jets can span thousands of light-years and influence star formation, galactic evolution, and interstellar medium dynamics. Observations of quasars and active galactic nuclei reveal some of the most luminous phenomena in the universe, powered entirely by these jets. Studying black hole jets helps astronomers understand extreme physics, energy transfer, and the interplay between black holes and their host galaxies. The existence of such jets demonstrates that black holes, though often considered destructive, can profoundly shape their cosmic environments in dramatic and visible ways. Fact 95. Rogue planets drift through space without a star. Rogue planets are celestial objects that drift through space without orbiting any star. Unlike planets in solar systems, they wander freely through the galaxy, untethered by stellar gravity. Rogue planets may have been ejected from their original planetary systems due to gravitational interactions or formed independently in interstellar space. Some may retain thick atmospheres, subsurface oceans, or even internal heat sources from radioactive decay, raising the possibility of exotic life in unexpected environments. Detecting rogue planets is challenging, often relying on gravitational microlensing, which observes the bending of light from distant stars as a planet passes in front. Studying these wandering worlds expands our understanding of planetary formation, dynamics, and the diversity of objects in the galaxy. Rogue planets remind us that not all planets are tied to stars, emphasizing the vast, untamed, and mysterious nature of space, where countless objects travel silently through the cosmos, unseen yet significant in the galactic landscape. Fact 96. Some galaxies are shaped like rings. Some galaxies in the universe are shaped like rings, a rare and fascinating type of galactic structure. These ring galaxies often form when a smaller galaxy passes through the center of a larger one, creating gravitational ripples that trigger waves of star formation. The result is a circular arrangement of bright, young stars surrounding a less dense central region. Ring galaxies can provide insight into galaxy dynamics, collisions, and the processes that drive star formation. Studying their structure helps astronomers understand how galaxies interact and evolve over time. Famous examples, like the Higgs object, reveal both the beauty and complexity of these cosmic formations. nitrogen, were forged in the cores of ancient stars through nuclear fusion. Stars act as cosmic furnaces, fusing hydrogen into helium and gradually creating heavier elements over their lifetimes. When massive stars die in spectacular supernova explosions, they scatter these elements across space, enriching interstellar gas clouds. Eventually, this material coalesces to form new stars, planets, and even living organisms. This process means that much of the matter in your body, and indeed on Earth, has a direct origin in stellar interiors. Understanding stellar nucleosynthesis, the creation of elements inside stars, connects astronomy to chemistry and biology, showing that humans are literally made of stardust. Studying the life cycles of stars allows scientists to trace the origin of elements, understand the chemical evolution of galaxies, and appreciate the interconnectedness of the cosmos. This profound realization emphasizes that we are an intrinsic part of the universe's grand cosmic history. Fact 100. Every element heavier than helium comes from stars. All elements heavier than helium, including carbon, oxygen, iron, and gold, are created in stars through nuclear fusion and during supernova explosions. Stars fuse lighter elements in their cores, producing progressively heavier elements up to iron. When massive stars explode, they generate even heavier elements through rapid neutron capture, dispersing these elements into space. This stellar material forms the building blocks for planets, life, and everything we see around us. The process of stellar nucleosynthesis highlights the vital role stars play in shaping the chemical composition of the universe. By studying these processes, astronomers gain insight into the formation of solar systems, the evolution of galaxies, and the origin of the elements essential for life. Recognizing that all heavy elements originate in stars underscores the profound connection between humans, Earth, and the cosmos, demonstrating that the universe is a continuous cycle of creation, destruction, and rebirth through stellar activity. Thank you for watching this journey through 100 fascinating facts about the universe. We hope you enjoyed exploring the mysteries of space, from the tiniest atoms in your body to the largest black holes and galaxies. The universe is vast, full of surprises, and there is always more to discover. If you enjoyed this video, don't forget to subscribe to Heavenly Sleep Stories for more amazing facts, stories, and discoveries from science, history, and beyond. Hit the notification bell so you never miss an episode, and share this video with friends who love learning about the wonders of the cosmos. Keep exploring, stay curious, and remember that every day is an opportunity to discover something new. Thank you for being part of our journey through the stars.